So let's review some of the concepts that I've mentioned here because they are just fundamental to everything. Data in a computer has a type. The types we generally think of as being types that are not specific to a particular problem, like integers, dates, floating point variables, strings, things like that. And from that we build applications that deal with specific things like customer names, birth dates, balances. And all of those have fundamental types associated with them. But they also have specific rules about what we'll accept. Can someone open an account in the future? Can someone have an age less than 0? Can someone have a name that has numerals in it? Well, sometimes if they're the third or whatever. But we have business rules that are associated with those data types, and the intrinsic data types of the computer don't enforce those. If I try to take 2 times an S, the computer isn't going to let me get away with that if I mean the character S of the alphabet and not a variable named S. So what we have to do is write into our programs business rules that keep invalid data from doing bad things, because if it's possible for that data to get in there, it's going to. We put invalid values in ATMs all the time. If you're like me, you put in the wrong PIN, you put in something, it's got to check it and tell us we've done it wrong, try again, reject what we've tried to do. Now, for programmer convenience, we have come up with the idea of a complex data type, which is a structure. And this gives a more human-readable form to a clump of data that consists of various subordinate pieces of data. So we can refer to a customer in our data just like we refer to a customer in real life and mean several pieces of data associated with it. But the problem associated with the business rules in that data is that every place that the data is referenced must still contain the business rules. Now, the concept of object-oriented programming is going to say, to the extent possible, we are going to make as much data as we can in things that look like structures, which are ultimately going to be called classes. And please, I do realize the difference, but I don't want to go there now. And so we're going to say, if you're dealing with customer data, you must make a data type called a customer. You must make a data type that's called a transaction that has a date and an amount and a type, whether it's a withdrawal or deposit, and another type of whether it's cash or check or money order. So when we refer to a transaction, we're actually referring to 4 sub-pieces of data. We're going to make definitions of data that are types. Okay, that we could already do. But what are we going to do next is we're going to have a programming language which is more human readable. We're not dealing with ones and zeros directly. A compiler for that computer language is then going to translate that into ones and zeros, but we're not going to be able to read that very easily. So we're going to deal with a language that has particular features built into its compiler, such that it lets us write certain kinds of code and not write other kinds of code. And this compiler is going to permit us to declare types like a customer account, and also declare intrinsic to that type operations which are valid and operations which are not valid that build upon the rules of the intrinsic sub piece of data. So if I have a balance, yes, it is going to obey the rules of operations to numbers, but it's also going to obey my rule that says that it can't be less than 0. And because that is going to be associated with the piece of data specifically, and so that just like you take an integer and you add it, we're going to take a customer account and we're going to deposit to it. deposit is going to become an operation just as fundamental to a customer account as addition is to an integer. But it's also going to have these other rules built in. So that means that when I want to deposit to a customer account, I cannot write code in a dozen different places that say add this money to the balance, because the compiler is going to say no, that's not permitted with this data type. We've made up a rule that is built into the data type that says if you are going to add to the balance, you must call a certain procedure called deposit. It's no longer optional. You can't go off and write in other places because you can't find the deposit procedure. You can't say, I can't find it, I'm going to write another one that manipulates this piece of data inside the complex piece of data. You must use this method, and the compiler is going to enforce that for us. And all of this turns out that object orientation is really a convenience for the programmer because it forces the programmer to use procedures that are written exclusively to manipulate the data in such a way that now the rules become encapsulated with the data type and cannot be circumvented. And so it prevents the programmer from doing foolish things intentionally or unintentionally. So now we have data that has types that go beyond integers and dates and strings. And they become types like customers and transactions and loans, and I know I'm sticking things in the financial world here, but we might have employees, and the employees might have data called properties associated with it. That's the employee name, the hire date, the salary, and that sort of thing. And there will be rules or procedures called methods associated with employee data or objects that must be followed to promote or demote or do some other operation associated with the employee object. When I was interviewed for a job a couple years ago, someone asked me the question, what is an object? And my simple answer was data. Now that answer would surprise a lot of object-oriented people because they are tied up with the ideas that I've expressed that we have data, but it must be accessed through these procedures. And so when we say what is the object, we want to say, well, it's also these procedures. But an integer is not addition and subtraction. Addition and subtraction are valid operations on an integer. So an integer is an object under the definition that I'm using here. And once we declare some piece of data to be of type customer or whatever, we have defined the operations that are valid on that data. But the operations are not part of the data, or, they're just not part of the data. They are associated with the definition of the data and the valid operations that can be performed.